These will be the related rate problem on your last quiz, and hours 1 and 2 had this one, and hour 6 had this one. I would suggest you watch both of them, the one you had so you can fix it if there were mistakes, and the other one just in case that's the kind you get on the test. And these are very typical related rate problems where we work with either cones or cylinders, and they're either leaking or filling up with something. And the cone tends to be more difficult than the cylinder just because it has the 1/3 out front. So if you can do the cone ones, you can do the cylinder ones, and I can almost guarantee on the test that you will get one or the other. The test has 4 different FRQ forms. So you don't know, you might get the ladder and the cone filling up, or you might get 2 cars driving and a cylinder leaking. But they're similar questions. And our one had this one, that the radius of a cone is decreasing at a rate of 2 inches per second. The minute I know I'm dealing with a cone, I'm going to draw a picture. It's actually called a right cone because it's perpendicular to the ground. It's not oblique or tilted or anything. But the radius of the cone is decreasing at a rate. That gives me a derivative, and it is the radius decreasing at that rate. So I have dr dt is equal to, and what I'm doing is I'm shrinking the radius. Now for this problem, I'm not filling the cone up and it's not leaking. What's happening is, you can kind of picture that I have it like heated and I'm changing its shape. So what I'm doing is I am decreasing the radius, but I'm increasing the height. And as I do that to this cone, it's going to cause the volume to change. And so this is dealing with both the actual cone itself, and the radius is changing, so that needs a variable. And the height is changing, so that needs a variable. And the volume's changing, so that'll be a variable. We'll call that V. And it says the height is increasing, so that'll give me a positive rate of change. So I'd write that as dH dt, and that would be dH dt equal to positive 5. And then my question, what do I need to find? At what rate is the volume of the cone changing? So I need dV dt, the instant when the radius is 6 and the height is 10. Those don't go on my picture. That's not what they are right now. That's when I am going to stop and take that screenshot in time. Remember, we sometimes put that in a little box, and that's when I'm going to kind of do my Snapchat, is right when the radius is 6 and the height is 10. I'm going to stop this process and see how everything's changing at that instant. So the first thing I need is a formula relating the quantities in question, and I gave you the formula, 1/3 pi r squared h. Before you move on with it, take a look at what you are needing to find and look at what you are given. My find and my given has all 3 variables in it. That's a clue to you're going to have to take the derivative of this as it exists. You're not going to replace with r with anything or h with anything because all 3 of these are involved. So I'm going to take the derivative of this. Before I do that, I even think I maybe might want to write 1/3 pi as pi over 3, just so I see that as being one big constant out front of this product of functions. That's very important what I just said, because most of you who got this wrong, you didn't use the product rule. And this is a product of functions. And so I'm going to take the derivative right now. Basically, taking the derivative kind of starts that clock. It starts the process going. So right now, what I'm starting to do is I am decreasing the radius while I'm increasing the height, making a skinny, tall, or narrow, taller cone. Everything's changing on that cone. And I'm going to take the derivative with respect to time of the left-hand side and the derivative with respect to time of the right-hand side. But constants come out front when we take the derivative of this product. And so really, I need to take the derivative of this. That's going to require the product rule. Many of you who got it wrong, you wrote 2r h dh dt. Can't do that. We have to follow our rules that say we do first, which would be r squared, d second. The derivative of h with respect to time is dh dt, plus second, which would be h, times the derivative of r squared, which is 2r times dr dt. R is itself a function of time, so it's a little implicit differentiation that I'm using there. What do I do now? Right now, I'm going to go take that screenshot. I am looking for the volume, its rate of change, at the instant when the radius is 6 and the height is 10. So I'm going to go over here, and I could even write it with formal notation. I'm going to stop for a moment in time and go figure out how the volume is changing at that moment. The pi over 3 will stay out front. In my beefy brackets, I will have r squared. R is 6, so that'll be a 36. I'll have dh dt, which I forgot. What's dh dt? 5. Then I'm going to have plus the height. At the time I'm taking that screenshot, the height will be 10. The radius will be 6. And dr dt was a negative 2. And I had the 2 out front, which I'm going to sneak in right here. All right, so I'm just going to clean this up, and that'll be my answer. I'm going to have pi over 3, pi thirds. 36 times 5 is 180. 20, 120. Negative 240. 180 minus 240 is negative 60. And that's times pi thirds, which is going to give me negative 20 pi, which was the correct answer. Those of you who put negative 20 pi, you still saw a point deduction, because these always need to have the proper label. Before you just throw anything on there, go look at what you found. You found the rate that volume is changing. So your label is volume, centimeters cubed, changing over time. And I believe this time was in seconds, or didn't it say? Yep, inches per second. Actually, that should be inches cubed. See? Good thing I scrolled back. This problem was in inches, so should be inches cubed per minute. So the volume's actually going down, which makes sense because I am making the radius smaller while making the height bigger, but the radius has more effect on the volume than the height does, because in the formula it gets squared. So shrinking that radius is going to have a greater effect on the volume than increasing the height usually. So that's that one. And then 6th hour, you still had a cone, but it was an entirely different situation. Your cone was a funnel, and I wasn't changing that shape of that funnel. And that funnel, or the radius or the height of the funnel wasn't changing. The funnel had 30 centimeters deep, so the funnel itself will remain 30 centimeters deep throughout the whole problem. And its radius of the funnel will remain the same. But what I'm doing is, I've got that funnel has some water in it, and that liquid is flowing out, so I'll make little drops here, at a rate of 12 cubic centimeters per second. And I'm looking for, well, what rate is the height of that changing? Well, the height of the water is varying, so I'm going to put a variable on it. The radius of the water will shrink as the water flows out of the cone. My task is to figure out at what rate is the height changing. So let's see what we have and then go find what we need. First of all, it says that the cone is 30 deep and 10 high. Basically what that means is they're telling you that the height is 3 times the radius, or you could say the radius is the height over 3. Either one of those is fine. You'll decide which one you need once you set up the problem. So liquid is flowing out. I know that dV dt is equal to negative 12, and it's negative because the water level is going down. Everything's decreasing. At what rate is the height changing? So I want to know dH dt at the instant when the water or the liquid in there is 20 centimeters deep. All right, so now here's the deal. My formula was given to me for a volume of a cone. It's 1/3 pi r squared h. This one's different than the other one. The other class had one where they needed to use the product rule because they couldn't set up proportions because it was the actual cone itself was morphing. This is not. I need to find dh dt when h is 20, when I know dv dt. Notice there is no r in this. And so what I'm going to do is get r out of here and replace it with its expression in terms of the height. So I'm going to replace that radius with 1/3 of the height. Some of you replaced it with 3h, so you got to be careful right here. The radius right here is 1/3 of the height. So the volume will equal pi over 3, the constant, the radius squared times the height. And for this one, I'm going to write the radius as h over 3. I'm just getting my formula ready to work with here so that I can find height when given information about the height and information about the volume. So I'm getting everything in terms of V and H before I start. I'm going to clean this up. I will have a pi here. I'll have a 3, and then 3 squared is 9, so I'm going to have a 27 on the bottom. I'm going to have h squared times h, so an h cubed, and h cubed as well. Now I'm ready. Ready to what? Ready to start having that leak out, ready to take a derivative, and then I'll stop it when it's leaked down to 12 centimeters in depth. So dv dt is going to equal the derivative of the right-hand side with the constant coming out front. So I'm going to do the derivative. Here, I'm going to write that better. My smartboard's been really finicky lately. It's kind of bothering me, but no, I'll deal. All right, so I'm going to rewrite that. dv dt, derivative of the left, will equal the derivative of the right. I'm going to pull the pi over 27 out front. I don't have to, but it makes life easier. And I'm going to do the derivative of h cubed with respect to the height. So really, I just need to do the derivative of that h cubed. I'm going to have pi over 27 times the derivative of h cubed is 3h squared times the derivative of the guts, and the guts is h. So dh dt. All right, and that's what dv dt equals. Now stop, take your screenshot. What's happening at your screenshot? The height is 20. I'm looking for dh dt, and they gave me dv dt. So I'm going to go replace what they gave me. They told me negative, was it negative 12? I feel like it was. Yep, dv dt was a negative 12. Remember, it was negative because it was leaking. If you forgot that, I took a point off. I'm going to reduce this because I like to simplify early and I like to simplify often. That's going to be a pi. H squared would be 36. Because h, we're stopping this, I believe, when h, I lied, it's not 6. When h is, that was on the last problem, when h is 20. So it's going to be 20 squared over 9. Where's the 9 coming from? I'm just canceling 3 over 27. I'm putting a 20 in for h. I'm in search of dh dt. Solving this, there's several ways you could solve it. You could do it 1 by 1, or you could call this 400 over 9 and multiply by a reciprocal. There's some options that you have. I'm just going to write it as negative 12. I'd multiply both sides by 9. I divide them both by pi times 400. Sorry, a bell just rang. And that'll give me my dh dt. I'm just solving for a variable by undoing this stuff. Multiply by 9, divide by these two, and I'll have it. Maybe we could take out and reduce our fraction. That would be nice. Let's divide both of these by 2. It'll give me a negative 6 over 200. Let's divide them by 2 again, negative 3 over 100. Remember, you didn't have a calculator for this, so on the top, I end up with a negative 27 left. And on the bottom, I end up with 100 and pi left. And that will be the most reduced form of my change in height. Now it needs a label. It's the rate that the height is changing. So the height changing over time. This problem, the height was given in centimeters, and this is per second. So we would write centimeters per, come on, second. Centimeters per second. There you go. And that's both of them. Make sure you are good at both kinds and know when you need the product rule and when you don't, because you never know what kind you're going to get. Oopsie. I want to pause this.